everyone. Welcome back. Today we have with us Varshini again. She'll take you through the spring 2024 paper 42 of IGCSE Mathematics. Over to you, Varshini. Let's
Hi
go.
everyone. So today we'll be going through this paper. Go to the first question. A grocer sells potatoes, mushrooms, and carrots, and in part A, a customer buys 3 kgs of mushrooms at a price of $1.04 per kg, and 4 kg of carrots at $1.28 per kg, and we need to calculate the total cost. Okay, so first, we know that we have to calculate mushrooms plus carrots. So we know that 3 kgs of mushrooms are all being sold at 1.04 per kg. So that means if 1 kg is being sold at 1.04, 3 kgs is going to be sold at 3 times 1.04. So that's basically 1.04 for each kg. And for the carrots, it's 4 kg at 1.28 per kg. So again, if there's 1.28 for 1 kg, there's going to be 1.28 times 4 for 4 kgs. So it's going to be this value plus this value. So again, all you need to do is, you need to put that in your calculator, and don't forget to add the brackets, and you should get 8.24 as your answer. Okay, to the next question. In 1 week, the ratio of the masses of vegetables sold by the grocer is potatoes is to mushrooms is to carrots equals 11 is to 8 is to 6. So potatoes is 11, mushrooms is 8, and carrots is 6. So work out the mass of the mushrooms sold as a percentage of the total mass. So for this, we don't really need the numbers. We have the ratios, and that's all we need because it's as a percentage. They don't actually want to know the true values. So we know that over here, mushrooms, we know that first of all, for the formula of percentage would be part by total into 100. Hold on, my bad. That's an into sign, cross multiplication sign. So over here, the part is we want to calculate is the mushrooms. So that's going to be 8 divided by the total, which over here is nothing but 11 plus 8 plus 6. So that's 11 plus 8 plus 6 and into 100. Because this would just be a fraction, but we want the percentage. So we're going to multiply into 100. So if you put that in your calculator, and don't forget to add the brackets over here, you should get 32. So that's going to be 32%. Okay. The total mass of potatoes, mushrooms, and carrots sold is 1500 kgs. Find the mass of carrots the grocer sells this week. Okay, so we know that the total is 1500, and we also know that from over here the total ratio is 11 plus 8 plus 6. So if we have over here, let's put it as a fraction, it's going to be 11, 8, and 6. So we know this total is going to be 1500 kgs. So, and we want to find how much carrots, and carrots over here is 6. 6. We want to find how much is this. So we know that that all of these added up together into some number will give us 1500. And we also know that 6 into that same number will give us 1500. So to find that multiplier, we're going to do 1500 divided by 11 plus 8 plus 6. And again, when you're putting this in your calculator, don't forget to add the brackets. 11 plus 8 plus 6. And you should get 60. So now we know that the ratio over here, we're scaling it up by 60. Each number is being scaled up by 60. So now to find the kgs of carrots, all we have to do is 6 into 60, and that should give us 360. Okay. The profit the grocer makes selling 1 kg of carrots is $0.75. Find the total profit the grocer makes selling carrots this week. So we know 1 kg of carrots is going to be 0.75. And for how many kgs of carrots do we have? We know we've calculated from the previous question. It's 360 kgs of carrots. So for 360 kgs of carrots, it's going to be 0.75 for 1 kg. So for 360, 0.75 into 0.75, 360 times. So there's going to be 0.75 into 360, because we're going to add 0.75 360 times since it's for 360 kgs. So all you have to do again is put that into your calculator, and you should get $270. So part 4. On the last day of the week, the grocer reduces the price of 1 kg of potatoes by 8% to 1.15. Calculate the original price of 1 kg of potatoes. 1 second. Yeah. Okay, so we know that the original price has been reduced by 8%. So we know that for percentage reduction, all we have to, the formula over here is it's going to be into 1 minus the reduction, or whatever this ratio, by 100. Okay, and that is going to be equal to, over here it says that it's equal to 1.15. And we also know over here that r is 8, so we can take that out and write this as 8. So this over here, original, is our variable, and we want to make this first. Let's calculate this. So just put this into your calculator. 1 minus, and over here this is in brackets. So 1 minus 8 divided by 100, and you should get 0.92. So we know O into 0.92 is giving us 1.15. Now all we need to do is make the original, this variable, the subject of the formula. So we need to get rid of the 0.92. So we're going to divide both sides by 0.92. And then all we have to do is calculate this, 1.15 divided by 0.92. And you should get 1.25. And so over that is going to be our answer over here, $1.25. Okay, part C. The grocer buys 620 kgs of onions, correct to the nearest 20 kgs. And he packs them into bags, each containing 5 kgs of onions, correct to the nearest 1 kg. Calculate the upper bound for the number of bags of onions that he packs. Okay, so we know over here that to calculate the number of onions, all we need to do, so the number of bags of onions is the total kgs, which over here would technically be 620 divided by the number of kgs, which is 5. But over here, they're giving us bounds, and they want us to calculate the upper bound. So for any upper bound of division, we know that the upper bound is going to be equal to the upper bound of the numerator divided by the lower bound of the denominator. And so over here, we know that it's correct to the nearest 20 kgs. So all we have to do to find this upper bound is going to be plus half of 20 into 20. And over here in the denominator, remember, we want the lower bound of the denominator. So that lower bound is going to, and over here it's correct to the nearest 1 kg. So it's going to be minus, because it's the lower bound, not the upper bound, half into 10. Half into 1. Sorry, my bad. Yeah. Common error a lot of people make is just they divide it and then they calculate the upper bound. But remember, we want to calculate the upper bound for the numerator and the denominator and then divide it. So over here, the upper bound for the denominator is nothing but 5 minus half into 1. And don't forget the minus for it because it's a lower bound. So you can just put this directly into your calculator, or you could simplify the numerator and denominator and then put it into your calculator. And either ways, you should get 140. So that's 140. Okay, for the next question. Question 2. Okay, so they've given us a figure and they're saying A, B, C, and D are points on a circle, and ADX and BCX, both of these are straight lines. Angle BAD is X, this is X, and angle BCX is Y. And they want us to prove that X equals Y, and we have to give a geometrical reason for each statement we make. Okay, so first, we know that angles on a straight line equals 180. So we can say 1 angles in a straight line equals 180 degrees. And so therefore, we know y degrees plus this angle BCD gives us 180. Okay, and now the second statement, we can also say for x. Now we have to look at x. We know that angles in a cyclic quadrilateral, opposite angles in a cyclic quadrilateral add up to 180. So we know that this angle plus, again, BCD is going to equal to 180. So we can say angles in a cyclic quadrilateral lateral are supplementary, which means they add up to 180. Don't forget to don't just write like these statements. You have to give the reasons, otherwise you won't get any marks. So over here, since we know that these angles are supplementary, we can also say that x plus BCD equals 180. So that's going to be x plus BCD equals 180. And over here, y plus BCD equals 180 and x plus BCD equals 180. So we can write it like here. Over here, BCD equals 180. And so since both of these are the same and these are the same, these two also have to be equal to the same thing. You could also, if you don't understand it this way, you can move BCD to the other side of the equation, and then you would get that x equals at 180 minus BCD and y equals 180 minus BCD. And so hence x has to be equal to y. Yeah. Okay, for the next question. Show that triangle ABX is similar to triangle CDX. So let's look at these two triangles over here. We want ADX, which is, ABX, which is this triangle, ABX, and CDX, which is this triangle. Okay, so first, we know we need to prove this, we need to show that two angles are the same, which would also mean that three angles are the same. Okay, so first, we know that this angle is the same because they both share this angle. So we can say that angle AXB equals angle this angle DXC, and instead of saying equal, you could also say they share the same angle. They both share the same angle. So that's one angle is equal. To find the next equal angle, we know we've just proven that angle x equals angle y. So over here we can also say angle x equals angle y. And since we know that over here the two angles are already similar, these two angles and this angle, we know that xdc has to be equal to abx because angles in a triangle always add up to 180. And since two angles are already similar, are already the same, the third angle has to be the same to make 180 for both triangles. So therefore we can say angle abx equals cdx. Angle ABX equals angle CDX. So now we can't just end it off here. We do have to say that three angles are equal, and so hence the triangles are similar. Okay. So now we'll go to the next question. AD equals 15 centimeters, dx equals 9 centimeters, and cx equals 12 centimeters. So we know AD is 15. Okay. And we also know dx is 9 and cx is 12. So over here, dx is 9 and cx is 12. Find BC. So they want us to find this line. So we've just proved over here that this triangle and this triangle are similar. So that means the scale factor will be the same for the sides that are equal. So we know that over here that this side is corresponding to is going to be corresponding to this side. And this side over here, CX, is going to be corresponding to AX. So what sides do we know? We know DX, and we don't know this full side. Yeah. So we know this entire side, and we also know this angle. So we also know this side. So we know the scale factor over here is going to be 12 divided by 15 plus 9, because that'll be this side and that's going to be this side. So we know that, and a lot of mistake a lot of people make will be thinking that this side is corresponding to this side. But remember, when the triangles are similar, we know that these angles are the similar angles, so it has to be that this side corresponds to this side. So first, let's find the scale factor, and we know over here that's going to be SF equals 12 divided by 15 plus 9. So if you put that in your calculator, you should get 1 by 2. So we know that now we know the scale factor. We know that dx over here, we know dx, this one, is going to be corresponding to this. And so we know that 9 into 2 is going to give us bx. And remember, so all we have to do now is scale this up. So we're going to do 9 into 2 equals bx, and bx is going to equal to 9 to 2, which is 18. Remember, they want bc, not bx. So to find bc, which is over here, all we have to do is subtract 12, which is cx, from the entire bx. So that's going to be BC equals 18 minus 12 equals 6. And so that is going to be our answer. BC equals 6. Okay, part 2, complete the statement. The ratio area of triangle ABX to area of triangle CDX equals blank is to 1. So remember over here, ABX is going to be this triangle, this whole triangle, and CDX is the smaller triangle. So, and we know we've already found the scale factor, that ABX over here, ABX is 2 into CDX, or we can just say 2 is to 1. Remember, this is the scale factor for the sides, but we want the scale factor for the area. And we know that area is nothing but area scale factor equals the scale factor of the sides whole squared. So if this is 2 is to 1, this is this area, the area scale factor is going to be 2 squared is to 1 squared, which is going to be 4 is to 1. And here they've already given us CDX as 1, and we know ABX is just going to be 4. Okay, to the next question. The table shows information about the marks gained by each of 10 students in a test. Calculate the range. So we know the range is the highest value minus the lowest value. So over here, that's just going to be, so remember, don't get confused between frequency and mark. Mark is the value of x, so you want over here. Frequency is just how many times x is appearing. So that's going to be 15 is coming 4 times, 16 is coming once, 17 is coming twice, 18 is coming once, 19 is not coming at all, and 20 is coming twice. So over here, we just want the highest value minus the lowest value. So that is going to be the highest value here, which is 20 minus 15, and that's going to be 5. So now they want the mean. So we know that the mean over here is nothing but the sum of the x value here, which is mark, into the frequency, how many times it's come, divided by the sum of all the frequencies. So all we need to, so that over here, that's going to be, let's like write it out manually. So that's going to be 15 into 4 plus 16 into 1 plus 17 into 2 plus 18 into 1 plus 19 into 0, which we can ignore because it's not coming at all, plus 20 into 2. And all of that is going to be divided by 4 plus 1 plus 2 plus 1 plus 0 plus 2. Okay, so put this in your calculator and don't forget to add the brackets everywhere. Over here there are brackets, and on top of here there are brackets. Or you could also just calculate the numerator separately and the denominator separately and then divide it, because that might be more easier. Okay, so
It's
once you do
also
this,
like, yeah, sorry.
yeah, yeah,
I was saying
go
for
on.
questions like these, sometimes people are in a hurry because they're like, this question we do know the steps to, so they forget sometimes. Like they might forget to do 17 into 2 and just forget about 17. Yeah, so like I was just saying that be very careful with writing down each of the mark and frequency.
Yeah, and this has a lot of numbers, so it's very easy to like forget a few numbers or like leave out stuff. So don't forget to like double check your answer. And if you do this, put this in your calculator, you should get 16.8. So I'm gonna write that over here because there's no space on the other side. But make sure in the exam you space out your working neatly and put the answer in the box. Now they want us to find the median. Okay, so over here, we know that the formula for median is nothing but n plus 1 by 2th value, Okay, so over here, the n over here is going to be the sum of the frequencies. So that's going to be, and we already know that it's 10 here. So it's going to be 11 by 2. And if you put this in your calculator, you should get 5.5. So and now we need to find the 5.5 fifth, the 5.5th value. So that's going to be 5.5. Okay, so over here it's 1, 2, 3, 4, and then 5 will be 16, and 6 is going to be 17. So 5.5 is going to be somewhere between 16 and 17. And so to find the 5.5 value, we just have to do 17 plus 16 by 2, or you could just say 17.5, because we know that the value in between 16 and 17 is going to be 16.5. So that's going to be 16.5. Okay, write down the mode. So we know the mode is the most frequent value. So that's going to be the value with the maximum number of frequencies, the value that's coming the most, repeating the most. And over here, we can see very clearly that 4 is the maximum frequency. So that is going to be 15 as the most frequent value. Okay, for the next question. Paulo's mean mark for 7 homework tasks is 17. After completing the 8th task, his mean mark is 17.5. Calculate Paulo's mark for the 8th task. So we have two bits of information. Over here, we know that his mean mark for 7 homework tasks is 17. So we know that x, let's take this as x, which is going to be the sum of all his 7 homework tasks. Or we can just say sum of x, divided by 7 is going to give us 17. And we know after completing the 8th task, his mean mark is 17.5. So the sum of x plus the 7th, plus the 8th task divided by 8 this time, because the total is going to be 8 instead of 7, is going to give us 17.5. So over here, we can to get first, let's calculate over here the sum of x, all these values, all the sum of the 7 values. So we just need to get rid of the denominator. So we're going to multiply both sides into 7, and we're just going to get 17 into 7, which is equal to 119. Let's put this in your calculator. And so we know over here that this is equal to 119. So all we have to do here is replace sum of x with 119. We can take this out and make this 119. And this is the value we don't know. So first we're going to get rid of the denominator by multiplying both sides by 8. So we're going to rewrite this 119 plus 8th value is going to equal 17.5 into 8. So let's do that now. 17.5 into 8. So you should get 140. And now to calculate 8th, let's just take out 119 by subtracting this from both sides. So we can get his 8th value equals 140 minus 119. So you just put this in your calculator and you should get 21, which is our answer, his mark for the 8th task. Okay. For the next question. Okay. The table shows the percentage scored by each of 100 students in their final exam. So over here, it's 0 to 30, and it's coming 12 times. 30 to 35, which is coming 18 times. 30 50. 50 to 60, which is coming 35 times. 60 to 70, which is repeating 20 times. And 70 to 100, which is repeating 15 times. On the grid, draw a histogram to show this information. So we know over here, so to draw the histogram, we know, as indicated by this, we know we need the frequency density. So I'm just going to make a third row over here, frequency density. And now we're going to calculate all the frequency densities. So we know that the frequency density is nothing but, let me put it over here, frequency density equals um, frequency by class width. And the class width is this value, 30 minus 0, 15 minus 30, and so on. So over here, let me just make columns. So we know that this is going to be 12 divided by 30 minus 0. So 12 divided by 30, which is going to give you 0.4. 0.4. Now this is going to give you 18 divided by 15 minus 20. Don't forget to put the brackets. 50 minus 30, which should give you 0.9. This is going to give you 35 divided by 60 minus 50, which is going to give you 3.5. Hold on. 3.5. This is going to give you 20 divided by 70 minus 60, which is 2. And this is going to give you 15 divided by 100 minus 70, which is 0.5. Okay, so now to draw the histogram, we know that this it's for this range 0 30 30 50. So let's label all the class widths. So first we have 30, and we know it's going to be, so first let's find how much each box is. We know that over here for 10 boxes equals 20. So one box on the x-axis is going to be 20 by 10, which is 2. And on the y-axis, um, each we know 10 boxes equals 1. So one box is going to be 1 by 10, which is 0.1. Okay, so now that we know this, over here we need to find um, these intervals 30, 50, 60, and so on. First, let's find 30. So that's going to be over here. This is 22 and so on. So 22, 24, 26, 28, and 30 is over here. 30. And now 50. So that's going to be 42, 44, 46, 48, and sorry, my bad. 50 over here. And don't just estimate in the middle because you could often get the wrong value. So make sure you have the exact line. Next, we need 70. So that's 2, 4, 6, 8, 70. And lastly, 100, which is already given to us. So now we just need the values on the y-axis. So the first one is going to be 0.4. So we know each value is 0.1, so that's 0.1, 0.2, 0.3, and 0.4. 0.4. And the next one is 0.9. So that's just going to be 1 minus 0.1. So it's going to be over here, 0.9. You don't have to label these, but it might be better and easier for you. Next we have 3.5, so that's 3.1, 3.2, 3.3, 3.4, and 3.5 in the middle of these two. And next we have 2, which is just this. It's already given over here, 2. And lastly we have 0.5, so that's going to be 1 above 0.4. Okay. So now we need to draw the histogram. Remember, there are going to be boxes. So the first one is going to be the box between 0 and 30, and it's going to be at the height of 0.4. So we can draw that over here at the height of 0.4. Just extend it. Sorry, man. And extend it downwards as well. Hold on. Sorry. Yeah. Okay, so for the next box is going to be between 30 to 50 and at the height of 0.9. So 30 to 50 at 0.9. And we can also draw it over here. And lastly, I'm just going to move that down. Okay. And the next box, and make sure you're using a really thin pencil when you do these, so it doesn't look like it's in between any values. So the next one is 3.5, which we calculated was over here, up here. So that's going to be between 50 and 60. Remember 50 and 60, so that's between these two. So from 60, I'm going to draw a line up to 3.5. And again from 3.5 down over here. And lastly, across. Okay, and for the next one, which is 60 to 70, it's going to be at 2. So this is the height we want. So let's draw one down from 2 to 70. Just make sure your lines aren't slanted and that they're at the right spot. Wait, sorry, my bad. Yeah. And now the line across. And additionally, when you're drawing these, make sure that all of these bars connect because it's a histogram, not just a bar graph. And for the last one, it's at 0.5 from 70 all the way to 100. So it's going to be all the way to 100. Is it at 0.5? No, it's not. Okay, and the last bar over here. Alright, so there we have our histogram. Question 4. Part A. The diagram shows a pyramid with square base BCDE. BCDE. This is the base, and the diagonal CE and BD. So that's CE and BD intersect at M, and the vertex F is directly above M. That's a straight line. This one with 9 centimeters is a straight line. Yeah. BE equals 12 centimeters and FM equals 12 centimeters. FM equals 9 centimeters. Calculate the volume of the pyramid. And they've given us the formula here is equal to 1 by 3 area of the base into the height. So first, all we need to do is calculate the area of the base. So we can see area of a square. We know that this is square because both sides are 12. So we know that it's going to be side squared equals 12 squared. And we know we can just put that in our calculator to get 144. So now all we need is h, and we know already h is equal to 9. So now let's just substitute these in the formula. So we're going to get 1 by 3 into 144 into 9. 144 into 9 into 1 by 3. And don't forget to put this accurately in your calculator. And you should get 432. Whoops. Yeah, 432. Okay, calculate the total surface area of the pyramid. So we want this triangle plus the back triangle plus the side triangle. So we know that all those triangles are going to be the same. So basically we just want this triangle into 4 plus the area of the base, because at the bottom it's going to be at a surface. So we already know the area of the base. So we can say over here base equals 12 squared equals 144. Okay, so now we need to calculate the area of one of these triangles. And we so basically all we have to do here now is draw a line down here. Okay? And so for um this triangle, which we know this is gonna wait, hold on, sorry, my bad. Yeah. We know this, and assuming this is the midpoint, this line from this line and all the way up. This is going to be a right angle triangle with with this as the right angle. Okay, so we can use that to calculate this because we need, so basically all we need to do to calculate this triangle, we need the height of this triangle, and then we can do half into b into h. So to find this height of this triangle, we're going to use this other triangle that we found over here, and we know over here that we already know that one side is 9. So let's draw this triangle again. And we know that this is 9. We also know that over here, we can say that we know that the square over here is going to be, we know that each side of the square is 12. And so we also know that that the full that the diagonal of the square over here, wait, sorry, we don't need to calculate that. We need, so we have the square, we have 12, 12, 12, and we want to calculate this length, which we know is going to be 12. So we also know that half that length, because we want it from here, so we know half that length, 12, is just going to be 6. So we can say that from this point to M is half of 12, which is 6. And this is 6. And we also know that for any right angle triangle, a squared plus b squared equals c squared. And so this hypotenuse over here is going to be, and of course we need to take this out to get just c, so we're going to find the square root of this. And so this hypotenuse is going to be equal to the root of 9 squared plus 6 squared. And if you put that directly in your calculator, you should get 3 root 13, which we're going to leave as this irrational number to make sure we don't mess up with the decimal places later on. So we're going to get this as 3 root 13. And so now we have this height of the triangle that we need. So we know we have this height of this triangle, and we also have the base here, which is 12. So we know that the triangle of EBF is going to be equal to half into h into b, and over here h we already know to be, which we just calculated as 3 root 13, and b as 12. So remember, we want triangle EBF 4 times, okay, into 4, because we want this this first side, this side, we want this side, we want the back side, and we want the side, and we know all these sides are going to be the same. So all we have to do is put in this in our calculator. It's going to be 3 root 13 into 12 into 1 by 2, or you could just say divided by 2, into 4. So you're going to get 72 root 13. So now we're not done here. We need to add this to our original base, which is 144. Sorry, I don't know why I wrote 14. 144. So it's going to be 72. So total surface area equals 72 root 13 plus 144. So again, just put that directly in your calculator, and you should get this number as 403 point, you should get 403 point, sorry, my bad, 403.59. So, but remember, we need to round this off to three significant figures. And if you round this off, it's going to round up because it's 5. So it's going to be 404. So we can take this out and make this 404 centimeters squared. Wait, so, hold on, yeah. Okay, for the next question, part B, the diagram shows a toy made from a cone and a hemisphere. The base radius of the cone and the radius of the hemisphere are both r centimeters. Uh, the slant height of the cone is 3r centimeters, and the total surface area of the toy is 304 centimeters squared. And they want us to calculate the value of r. So they've given us two surface areas. The curved surface area of a cone is pi rl. So we know that over here, we can sum up these surface areas. We can say pi rl, which is the surface area of the curved surface area of this cone, plus they've given us the curved surface area of the sphere, of a sphere, which is 4 pi r squared. Remember, this is a hemisphere, so we want only half the sphere. So we're going to make this 4 pi r squared divided by 2. So it's going to be 4 by 2 pi r squared, which is basically just 2 pi r squared.
Yeah, this is like a common trick they use. They'll always like it's in hemisphere and they give the formula for a full sphere. Yeah.
Yeah, so don't forget, it's a hemisphere, not a sphere. So pi r L plus 4 by 2 pi r squared is going to give us the total surface area, which they've given us to be 304. And we can also make L, we also know L over here is 3r. So we want to get rid of all these extra variables. So we can say pi into, and remember, it's going to be r into 3r, which is going to give, okay, we can start this, r into 3r plus, and 4 by 2 is 2, so that's going to be 2 pi r squared equals 304. So now we know r, let's put the brackets over here, remember, don't forget the brackets. So we know r into 3r, these have the same variables, so we can multiply these, and we can multiply everything, but we know that r into r is going to give us r squared, so that's going to be pi into 3r squared, hold on, r squared, or we can instead write this as 3 pi r squared plus 2 pi r squared is going to give us 304. And again, we can see that this is going to be equal to this variable. And so we can just add these coefficients in front to give us 3 plus 2, which is 5 pi r squared, gives us 304. And over here, they want us to find r. So now we're going to have to get rid of 5 pi on both sides. So we're going to divide both sides by 5 pi. And if you put that in your calculator, remember to use the pi sign. That's 304 divided by 5 into pi. And just use the pi sign in your calculator. Don't use like 3.14 or anything. So you should get r squared equals 19.35, some number. So don't simplify that, just leave that in your calculator. So we want r and not r squared, so we're going to square root both. So to get r, we're going to square root both to get r. Just take the square root of this number that you've gotten in your calculator, and you should get 4.399 something. Remember, 3 significant figures. So to round this off, it's going to become 4.40. So don't remember, you have to leave in the 0 because they want 3 significant figures. 4.40. So when you round this off, it would be to the fourth 3 significant figures. You would have to round this off, 9, which should be rounded off to 10. So you move that over and you get 4.400. So don't forget the 0. Okay, for the fifth question, factorize x squared minus x minus 12. So we know over here how to factorize these equations. We know that firstly, we're just going to take what's common between, first we're going to add up, we're going to multiply a and c. And we know over here this is going to be a, this is going to be b, and this is going to be c. So we're going to multiply a and c, the coefficient. So this is nothing but 1. So that's going to be 1 into minus 12. Don't forget the minus sign. And we also know that the b term over here, the coefficient is minus 1x. So b is minus 1. B equals minus 1. So now we're going to split the middle term, which is minus 1x, to two numbers that multiply to give us minus 12 and add up to give us minus 1. Okay, so now we're going to write the factors of minus 12. So first we have minus 2 and 6. So minus 2 and 6. And that will also be, again, we have 2 and minus 6. Okay, next we have 1 and minus 12. And also minus 1 and 12. And lastly, we have 3 and minus 4. And minus 3 and 4. Okay, so now we have to see which of these two numbers adds up to minus 1. So we know that all of these two numbers multiply to minus 12, but which of these actually adds up to minus 1? So 6 minus 2 is not going to be minus 1, it's going to be 4. 2 minus 6 is minus 4. 1 minus 12 is minus 11. Minus 1 plus 12 is 11. 3 minus 4, if you put this in your calculator, it should give you minus 1. So we can select these. So once you do these for a long time, you can do this in your head instead of writing this down, and it becomes much faster. So now we have the splitting of the middle term, which is going to be 3x and minus 4x. So we can rewrite this as x squared minus plus 3x minus 4x minus 12. Okay, yeah. And now we need to factorize this. So we're going to factorize first these two terms, and then we're going to factorize these two terms. So we can take over here what's common between x squared and 3x is x. So we're going to take x out and put the rest in brackets. So we know x squared divided by x is nothing but x. So that's going to be x plus, and we also know that over here 3x by x is 3, so that's going to be plus 3. So now we're going to factorize these two terms, 4x and minus 12. So what's common between minus 4x and minus 12 is the factor minus 4. We're going to take minus 4 out, and in the brackets it's going to be minus 4x divided by minus 4, which is going to be x, plus minus 12 divided by minus 4, which is just going to give us 3. And again, we can see over here that these terms in brackets are common. So we can take that out and make this x plus 3 into this term and this term, which is x minus 4. And that is our answer. You can rewrite it again in this line so the examiner knows what your answer is. Okay, for the next question, simplify this. They want to simplify this. So we've already simplified this by factorizing the denominator. So now we need to factorize the numerator. So it looks familiar. We know that the expression of a squared minus b squared is going to give us a minus b into a plus b. So we want our numerator to look like this. We want it to look like a minus b into a plus b. Yeah. So, and we also know that 16 over here is 4 squared. If you're confused about whether this is a square number, you can always just put root of 16 in your calculator, and you should get 4. So we can also read out the top numerator as x squared minus 4 squared. And now it looks exactly like this formula. And we know that this is going to be a minus b into a plus b. So we can make this x minus 4 into x plus 4. And we've also already factorized our denominator over here as x plus 3 into x minus 4. So all we have to do is rewrite this as x plus 3 into x minus 4. And now we can also see that over here x minus 4 is on both the numerator and the denominator. So since they're both multiples of the top and the bottom, we can cancel them out and divide both the numerator and denominator by x minus 4. So the numerator is being divided by x minus 4. So that's why you can take it out of the numerator. And so you're going to get x plus 4 divided by the denominator, which is now just x plus 3. And that is our final answer. And again, you can rewrite it inside the dotted line. So part B, simplify 2x minus 3 whole squared minus x plus 1 whole squared. So to do this, we need to expand everything in the brackets. It's going to be 2x minus 3 whole squared. So we know that okay. We know that for a plus b whole squared, this is going to be equal to a squared plus b squared plus 2ab. So over here we have this in that formula, in that format. So we know that over here 2x is a and minus 3 is going to be b. Minus 3 is b. So now so now it's going to be a squared plus b squared plus 2ab. So a squared is nothing but 2 squared and x squared, which is 4x squared plus b squared, which is minus 3 squared. And if you put that in your calculator or just do it manually, you should get 9 plus 2ab. And so that's going to be 2x into minus 3 into 2. So that's going to be 2 into 2 into minus 3 into x. So all you have to do is put 2 into 2 into minus 3 in your calculator. So you get minus 12. It's going to be, and you can take out this. So minus 12 into x. Okay, so now we have expanded this first one. So now we're going to expand the second one. Minus, so let's write what's over here. So we know it's nothing but x squared plus 1. So a squared will be x squared. B squared will be 1 squared, which is just 1, plus 2ab is going to be 2 into 1 into x, which is 2, and 2 into 1 is 2, so that's going to be 2 into x. But remember, don't forget, there's a minus sign in front of this whole thing. So now we need to multiply each of these signs into minus 1. So it's going to be minus x squared minus 1 minus 2x. So now that we have the first equation, the first one expanded and the second bracket expanded, we can add these up. So we can just move this up here and make the we can just move this one, 4x squared, we can just move this to the side and rewrite this. So 4x squared plus 9 minus 12x. So now you have these, we can easily just add them up. So we have minus 12 and minus 2x, minus 12x and minus 2x. And since they both have the same x term, we can just add them up. So we know minus 12 minus 2 is going to give us minus 14x. And this also is numbers, so we can do 9 minus 1, which is 8, plus 8. And lastly, we have 4x squared minus x squared, which is going to give us 4 minus 1 into x squared, which is 3x squared. And this is our final equation. So again, we can just rewrite this inside the dotted line. Sorry. Okay. Part C, write as a single fraction in its simplest form. So they've given us two terms over here. So we know that to make this into a single fraction, we're going to have to make the denominators the same. So over here, when they have an x term, to make the denominator the same, the denominator is just going to be x plus 1 into x minus 3. Okay. So now we have to multiply each numerator. So 2x minus 4 has to be so now we're multiplying this entire fraction into x minus 3. And we're going to multiply this entire fraction into x plus 1. So we already have the common denominator. So now we just expand the numerators. So we're going to have to do 2x plus 4 into x minus 3. So we know for this, we're going to have to multiply both 2x into x and 2x into minus 3 and 4 into x. That on top. 4 into x and 4 into minus 3. So that's going to give us, first, let's do 2x into x, which is going to be 2x into x, and you know x into x is going to be x squared, plus let's do 2x into minus 3. So we can multiply 2 into minus 3 and make this minus 6x. Don't forget the x over here. And lastly, we have to multiply 4 into both terms. So we need plus 4 into x, which is just 4x. And again, plus 4 into minus 3, which you can put in your calculator, and it's going to be minus 12. So we can simplify this because minus 6x and minus 4x both have the same x term. So we can add these x terms up and make this 2x squared. And we know minus 6 plus 4 is going to be minus 2x, minus 12. So now let's expand the second fraction. It's for the numerator. We're just going to do minus x. Don't forget the minus sign in front of this. Minus x, which is over here, minus x, into x plus 1. So over here again, we're going to put x into minus x and minus 1 into minus x. So we know x into minus x is going to give us minus x into x, which is going to be x squared, plus 1 into minus x, which is just minus x. So we can take this out. Minus x. So now that we have the numerator, we can rewrite this as 2x squared minus 2x minus 12 minus x squared minus 2x. And we've already figured out the denominator, which is just x plus 1 into x minus 3. To x minus 3. So we can simplify this because there are two x squared terms and two x terms. So we know 2x squared minus 2x squared over here minus x squared over here is going to give 2 minus 1, which is just x squared. So when we read this, first we're going to do 2x squared minus x squared, which is going to be x squared. Then again, we have minus 2x over here and minus 2x. It's going to be minus 2, which will just give us minus 4x. And again, we have this minus 12 term, which we can just rewrite over here, divided by the denominator, again, which is the same, x plus 1 into x, x minus 3. Don't forget to make sure your answer is clear so the examiner knows where you've written the answer. And so that is going to be our final answer over here. Sorry, wait. This is going to be x squared minus x, not minus 2x. So that will make this minus 3x. Yeah. Okay, for the next question, expand and simplify x minus 3 into x minus 5 into 2x plus 1. Okay. So for this, we're going to multiply. First, we're going to take these two terms, and then we'll multiply into the second term. So that there we have x minus 3 into x minus 5. So again, we're going to multiply this into this, and this into this, and then minus 3 into x, and minus 3 into minus 5. So that is going to give us, first we know x into x is going to give us x squared, and we know x into minus 5 is going to give us minus 5x. And then we have the minus 3, so minus 3 into x is going to give us minus 3x. And again, minus 3 into minus 5, you can put that in your calculator if you're a little confused. But best to put in your calculator to always recheck, so you're going to get plus 15. So then again, we have these two similar terms, minus 5x and minus 3x, so we can add them up. And we know minus 5 minus 3 will give us minus 8. So that's going to be x squared minus 8x plus 15. I have to multiply this entire thing into 2x plus 1. So again, all we have to do is multiply 2x into all of these terms and 1 into all of these terms. So first, multiplying 2x into all of these terms, we're going to get 2x into x squared. So we have the similar x term, so it's going to be 2 into x, x squared into x, which will give us x cubed. And then we're going to do 2x into minus 8x, which is going to give us, first let's do 2 into minus 8. Then 2 into minus 8 will be minus 16. Then let's do x into x, which will be x squared. And then we have 2x into 15. So we just have to multiply 2 into 15, which will give us 30. And don't forget the x, so that will be plus 30x. And lastly, we have to multiply 1 into all of these terms, which is just going to be all of these terms again. So we can just write that below over here. So that's going to be plus x squared minus 8x plus 15. Okay, so now we have these similar terms. So we just have to add minus 16x squared and x squared, and 30x and minus 8x. So we can rewrite this. First, we're going to put, again, 15 at the end. Now we have 30 minus 8. So if you put that in your calculator, you should get 22x. And lastly, minus 16 plus x, which again should give you minus 50. Minus 16x squared plus x squared, to give you minus 15x squared. And finally, the first term, which we're just going to bring this right down because there's no other term to add it with, so 2x cubed. And that is your final answer. You can rewrite it again in the dotted line. Okay, part E, solve the simultaneous equations, and you must show all your working. So we have x minus 3y equals 13, and 2x squared minus 9y is giving us 116. So to do this, either we can put both equations in terms of x, or we could put, we could substitute, or we could put them in terms of y. And since there's an x squared over here, it's better to put them. It's better to put them, because of this x squared, we don't want to get into make this too complicated. So we're just gonna put this equation in terms of y first. So let's make y the subject of the formula. So we're gonna subtract x from both sides to get rid of this x first. It's gonna be minus 3y equals 13 minus x. And now we just have to get rid of minus 3y, so we're going to divide both sides by minus 3. Okay, so now we have y. And we also have this equation. So all we have to do is substitute this equation. So we know that this equation, y is equal to 13 minus x by minus 3. We know that this is equal to y, so we can substitute this value of y into the value of y in the second equation. So we're going to rewrite this and make this 2x squared minus 9 into y. And we want everything in terms of x. So we're going to put that value of y that we just got. So we're going to put minus 9 into 13 minus x divided by minus 3. And we're just going to equate that to 116. So now we can expand this. We know that over here, all we have to do is, we know minus 9 divided by minus 3. If you put that in your calculator, it's going to give you 3. So we can take this out and rewrite this as 3. Okay, so again, let's simplify this. 2x squared plus, remember, minus 9 minus divided by minus 3 is going to give us plus 3, not minus 3. So that's going to be plus 3 into 13 plus again, so 3 into 13 and 3 into minus x. So you put 3 into 13 in your calculator, you should get 39. So plus 39, again, plus 3 into minus x will give us minus 3x is equal to 116. So now we have x4 and we have x. So let's put this into the form of a quadratic equation. So we're going to get 2x squared minus 3x. Now let's take 116 on the other side by subtracting 116 from both sides. So it's going to be 39 minus 116. 39 minus 116. And you should get minus 77 equals 0. So now we have this in the form of a quadratic equation, a, b, and c. And remember, they want us to show all are working. And we know for any quadratic equation, the answer value of x is going to be minus b plus minus the root of b squared minus, b squared minus 4ac, and divide the whole thing by 2a. So now we just have to substitute these values into here. So that's going to be minus 3 into minus 1, which will, as we know, minus 3 is b. So minus 3 is going to give us 3 plus minus the root, okay, over here, which is going to be b squared, which we know minus 3 squared minus 4 into a. So minus 4, and over here we know a to be 2, so minus 4 into 2, into 2 into c, which over here is minus 77. Don't forget the negative value. So minus 77, and divide the whole thing by 2 into 2, which is 4. So now from here, you don't need to, you could either just put this in your calculator, calculate with first 3 plus all of this by 4, and then 3 minus the root of this by 4. Or you could just use the quadratic equation formula in your calculator and type in all the values of x squared and x, and make sure you do this to recheck that your answer is right. So if you type in the values in your calculator, or you could just use your formula, you should get x1 equals 7 and x2 is going to equal minus 5.5. Okay, so now to calculate both of our y values, all we need to do is substitute x into this, which is, so we know that y1, let me section this off. Y1 is going to be 13 minus x, which here is going to be 7 as x1, divided by minus 3. If you put that in your calculator, you should get minus 2. So we can write that as y1 and y2 is going to be 13 minus 5.5, don't forget the minus sign, divided by minus 3. And we also know minus minus is plus, so we can just write it like that. If you put that in your calculator, you get minus 6.1666. And if you just want to switch that to a fraction, you can write that as minus 6 1 by 6. Or you could just write it as minus 37 by 6. Either way works.
Yeah, but like don't confuse the values. Like when you put in 7, you got y equals minus 2. So just don't interchange the values when you write them in your final answer.
Yeah, make sure that x1 and y1 is with the same substitution. Question 6. The diagram shows triangle ABC with AB equals 17.2 and angle ABC equals 54 degrees and angle ACB equals 68 degrees. For part A, calculate AC. So we can see AC over here is this length. So yeah. So to calculate AC, we have two angles and we have a side. So we know we can use the sine rule where sine A divided by its opposite side is equal to sine B, which is a different angle in the triangle, divided by that's opposite side. So that would be, in the case of this triangle, ACB, this angle 68 divided by 17.2, this side, is going to equal 54 divided by this side, AC. So we can just write that and say sine 68 divided by 17.2 equals sine 54 divided by AC. And now to find AC, all we need to do is cross multiply. So if we do this, we should get AC into sine 68 will give us 17.2 into sine 54. And now to get rid of the sine 68, all we have to do is divide both sides by sine 68. So we're just going to divide this by sine 68. So now just put this in your calculator. 17.2 into sine 54 divided by sine 68. And you should get something around 15.01. Remember, we need to write it in 3 significant figures. So we're just going to write AC as 15.0. Okay. Question part B. M lies on BC and MC equals 12.8. So over here, we can clearly see this point, and they're telling us that MC is equal to 12.8. So that's MC, this length, which they've already shown us is 12.8. They want us to find, they want us to find AM, which is this line that they've drawn. Oh, yeah. So they want us to find AM. So we can see that over here it's a smaller triangle, and we already know that MCA is equal to 68 degrees, and we've also calculated AC to be 15. Hold on. Yeah, 15. So again, here we have two sides and we have an angle and we want to find the third side. So for this, we can use the cos rule where we know that cos of C, or lowercase c, let's put it here, is going to equal a squared, hold on, yeah, a squared plus b squared minus c squared, minus c squared divided by 2ab. So over here We have this C, we have lowercase c, and we don't have uppercase c, so this is the one we need to find, this big C squared. We have the small c over here, which is 68 degrees. And over here, A and B would be 12.8 and 15, in whichever way you want to take it. So if we substitute everything into this formula, we'll get cos 68 equals a squared plus b squared, which will be 12.8 squared plus 15 squared, plus 15 squared minus c squared. We're going to leave this as a variable because we don't know what it is yet. We need to calculate for this. And divided by 2 into 12.8 into 15. Okay, so for this, all we need to do first, let's get rid of this denominator over here by multiplying both sides by this. So first, let's calculate this in our calculator. Or we can first we can find everything else simplified, but I think it's better to solve for c squared. So 2 into 12.8 into 15, if you put that in your calculator, should give you 384. So now we're going to multiply both sides by 384. So 384 cos 68 equals 12.8 squared plus 15 squared minus c squared. Remember, we want to make c squared the subject of the formula. Okay, so we're going to have to move everything else to the other side. So that's so we have to subtract 12.8 squared and 15 squared from this number. So let's find our first we can rewrite this. Hold on, I'll just make some way. Okay, so now remember we need to make c the subject of the formula. So again, we're going to have to move everything to the other side. We can simplify this 12.8 squared plus 15 squared. If you put that in your calculator, it should give you 388.84. So now we can make this 384 cos 68 minus 388.84 gives us negative c squared. So now we have this in our calculator. Remember, this is not c squared. This is minus 1 into c squared, really. So what we have to do now is divide this entire thing by minus 1, or even multiply it. It's really the same thing. And then take the square root of that. So now all you need to do is put that in your calculator into cos 68. And if you're putting everything in your calculator at once, then don't forget to add the brackets. And if you get a minus sign with just this equation, don't be scared. It's because you need to multiply the full thing into negative 1 anyways. Yeah, and then you take the root and you should get 15.65. And remember, round it off to 3 significant figures. So the 6 will round up and we should get 15.7.
Also, like, it's always better that you show the actual value that you got. Like here we got 15.65, and then show that you rounded it off,
Yeah,
because
they like it
sometimes.
to a minimum 4 significant figures. Um, and then you show that you need to round it off so that they know what you're doing and where you've gotten the answer from. Okay. Calculate the shortest distance from A to BC. Okay, so let's go back up and let's look at A over here. We want the shortest distance from A. So if we did that over here, that would be a straight line down from A to BC. Remember, the shortest distance is always a straight line, so it's not crooked or slanted. And with the shortest distance, we would also get, remember, because it's a straight line, we should get a right angle over here. And so let's label this point X, and that would make our triangle ABX into a right angle triangle. And from here, it's really easy to calculate the shortest distance because we do know that for a right. Wait, let's redraw triangle ABX over here. So XAB, and this is a right angle, and we already know that AB is 17.2. 17.2, and this angle over here is 54. So now that we have this, we want to find the shortest distance from A to this line, which will be AX, and we know that sine theta, if you remember SOHCAHTOA, equals opposite by hypotenuse. And over here, that would be over this angle. If we took sine of 54, we get its opposite, the opposite of this, which is AX. So sine 54 equals AX divided by the hypotenuse. So since this is the right angle, this will be the hypotenuse. And the hypotenuse is 17.2. So AX divided by 17.2. Yeah. Okay, so now to calculate AX, we're just going to have to make AX the subject of the formula. So we're going to multiply both sides by 17.2. So AX equals sine 54 into 17.2. And again, just put that in your calculator, and you should get 13.92. Sorry, 13, wait, hold on. Sine 54. Yeah, you should get 13.92. Or, I mean, 13.9150, really. But, I mean, 09. But remember, we need to round off to three significant figures. So we can make this 13, 13.9. So 13 point. Okay, part 7a. They're given us two vectors. P equals 8 and minus 5. So we know that as vectors, it moves 8 in the x-axis and minus 5 in the y-axis. And the same for Q, it'll move minus 4 in the x-axis, which is and 5 in the y-axis. So what do these minus signs mean? Here we know P is just moving. For example, if we drew a grid, P would be 8 along the x-axis and minus 5, so that would be downwards in the y-axis. This would be P. And Q would be minus 4 in the x-axis, so we'd be going backwards 4, and 5, which would be upwards 5, somewhere over here. So this is Q, and this is P. Okay, now they're asking us to find 3Q. So you know that for when you multiply a vector, you have to multiply both the x component and the y component. So this would be 3 into minus 4 and 3 into 5, like that. So you can put that in your calculator or do it mentally, and either way you should get minus 12 on top and 15 in the bottom. And remember, don't ever simplify your vectors. They're not fractions, so you can't divide these by 3 and like simplify it. Just keep it as it is. Okay. Next part 2. A, find P minus Q. So again, when we're doing this, remember we need to multiply. When we do minus Q, we're subtracting both the x component and the y component from P, not just the x component. So it's going to be P, which is 8, minus Q, which is going to be minus 4. So that's minus 4. And on the bottom, subtract the y components. So that's going to be P, which is minus 5, minus Q, which is just 5. Okay. So if you put that in your calculator, or again, do it mentally. And remember, 2 minuses equal a plus. So if you put this, you should get 12 on the top and minus 10 at the bottom. And again, don't simplify it, leave it like this is. Okay, find the modulus of P, sorry, not the modulus, find the find the absolute value of P minus Q. So when they have these signs, what do they mean? They mean they want us to find the real length. They don't just want an answer P minus Q. So we know we've already found P minus Q over here, 12 and minus 10. So how do we find the length of this vector? we have to take we know the formula of this is going to be root of x squared plus y squared. So that over here is going to give us root of 12 squared plus minus 10 squared. And remember, the whole thing is getting squared. It's not minus and then just 10 squared, but minus 10 whole squared. So we put that in your calculator. You should get 15. You should get an irrational number, but just switch that to a decimal, and you should get 15.62. So round it off, and we'll get 15.6. Okay. Part B. In triangle OMN, O is the origin. That's this. This is the origin, which is 0, 0. OM is equal to A, and ON equals B. S is the point on MN over here such that MS to SN equals 5 is to 3. So we know that MS is 5 parts and SN is going to be 3 parts. And the total over here is going to be 5 plus 3, which is 8. So we can also write this as 5 by 8 of MN, which is this entire thing. And this is going to be 3 by 8 again of MN. Okay. First, they want us to find in terms of A and or B the position vector of S. Okay, and the position vector means, as we know, it's from 0. They want us to find this. Okay, give your answer in its simplest form. So how do we find OS? In a sense, they want OS. So we can do this by going this way. To find OS, we can do OM plus MS, or we could do ON plus NS. So let's go the first route. Let's go OM plus MS. So for OM, so OS equals OM plus MS. Okay, and we know OM over here is A, nothing but A, which they've already written, plus, and MS over here we already found is going to be 5 by 8 of MN, as MN is the total, and MS is 5 parts and SN is 3 parts, and the total is going to be nothing but both the parts together, which is 8, and we only want 5 out of those 8 parts. So that's going to be 5 by 8 into MN. So now we need to find MN. Okay, so let's find MN. So MN, which is going to be this length, I want us to find this. Okay, we can go this way. We can go MO. Yeah, so we can go this way from MO to ON. So we know MO, remember it's not A because A is in the upward direction. We're going down A, so it's going to be minus A. So it's going to be minus A plus, and again ON, which is they've given over here B. So we found MN, which is going to be minus A plus B, and now we need to put that in this over here. So to find OS equals A plus 5 by 8 of minus A plus B. Okay, now that we have this, we can't leave it like this. We need to expand out these brackets so that we can put the A terms together. So we can make this A, and now we have to multiply 5 by 8 into minus A, which will just give us minus 5 by 8A. And again, let's multiply 5 by 8 into B, which will just be 5 by 8B. So now that we have A minus 5 by 8A, we can simplify this because these are the same terms, A and A. So in a sense, all we're doing is 1A minus 5 by 8A. So that will give us 3 by 8A plus 5 by 8B. Okay. If you're confused about this, you can always put it in your calculator. So 3 by 8A plus 5 by 8B. Okay. On the axis, sketch the graph of y equals 4 minus 3x. Okay, so remember for this, we don't need every single plot and every single value. All we need is the y-intercept and the x-intercept. Okay, so first, let's find the y-intercept. We know that so let's rearrange this first of all, y equals 4 minus 3x in the formula of y equals mx plus c. So we can, so we need to put the x term first. So we can say y equals minus 3x plus 4. Okay, so minus 3 over here is going to be m, which is the slope, and 4 is going to be the y-intercept. Okay, so we know 4 is the y-intercept, we can label that over here. Again, we don't need to measure or do anything, just label the points. And now we need to find the x-intercept. So the x-intercept is going to happen when y is equal to 0. So for that, all we have to do is put 0 in this y coordinate. So we make this 0 equals minus 3x plus 4. So let's make x the subject of the formula. We can easily just subtract both sides by 4. Minus 4 equals minus 3x. And again, to get rid of the minus 3, let's divide both sides by minus 3. And we have x equals minus 4 by minus 3. And if you put that in your calculator, you should get 1.333. So let's just leave that as 4 by 3. But we also know 1.333 is going to be somewhere over here. If we're assuming that this is 4, that this much is 4 on the y-axis and this much would be 4 on the x-axis. So let's just write this as 4 by 3. And we know x is going to touch here and y is going to touch here. So if we make that a line, something like this. But remember, don't obscure the values that you've written. You need the examiner to see those. Yeah, so write it outside 4 by 3. And get rid of anything that looks messy or like unneat when you're actually doing it. Okay. On the axis, sketch the graph of y equals minus x squared. That's y. So the first, we can see that this is clearly not a linear equation. This is a quadratic, because there's a squared value. So again, we can let's find. First of all, we know that whenever there's a negative gradient, that is going to be a downwards opening parabola. So it's going to look something like this. Easy way to remember this. Remember, whenever there's a minus, it's going to be a sad face, something like that. And the parabola is going to open downwards. And if it's a happy face, it's going to be like this. And the parabola is going to open upwards. So in this case, we have a downwards opening parabola. So we don't really need anything more, but we can also find the x-intercepts and the y-intercepts. So we can first let's make x 0 to find the y-intercept, which is when x is 0. So that would just be 0. So over here we know this is going to be 1 point. Okay, yeah. So now we can also put this in the formula of y equals minus x squared, and we know that for whenever we write this for a quadratic equation, we can put this as what minus x plus a whole squared plus b, and over here a would be the turning point. Here we can clearly see there's no number, so that means it's 0. So if you rewrite this, y equals minus x plus 0 whole squared plus 0. So we also know the turning point over here is just going to be 0, comma 0. I mean, normally it would have been minus a, comma b, but over here it's just going to be 0, comma 0 because there's 0, a is 0 and b is 0. So over here would be our intercept, and since it's a downward opening parabola, remember not to make your thing too squiggly. It needs to be one clean line. Since I'm drawing on the computer, it's a little bit squiggly, but yours should look more neatly drawn with no squiggles. Okay, part C, first, the first part, find the coordinates of the turning points of the graph y equals 10 plus 9x squared minus 2x cubed, and you must show all your working. Okay, so we know to find the turning points, we know that dy by dx is going to be equal to 0. So first let's find dy by dx. So to do this, okay, we know that, first of all, we know that dy by dx of any constant is going to be 0. That's 10 plus. So now the formula is going to be 2. So if we have any, we know to find dy by dx of a into x to the power b is just going to be ab x to the power b minus 1. So now let's just apply those for these terms. 9 into 2 is going to be 18 x to the power 2 minus 1, which is just 1. Okay, minus 2 into 3 is going to be minus 6 x to the power 3 minus 1, which is just 2. Okay, so now we have dy by dx. We need to find when this is equal to 0. Let's rewrite that over here. 18x minus 6x squared equals 0. So first we need to factorize this. So we can see that x is on both of these terms, and we also know that 6 goes into both of these terms, 3 times into 18 and once into 6. So we can factor out 6 and x. We can take these outside. And if we divide 18x by 6, if we divide 18 by 6, we'll get 3, and x by x will just be 1. So that will be 3. And over here, we're going to divide minus 6x squared by 6x. So minus 6 by 6 is going to be minus 1. And x squared by x will just give us x. Okay, so now we have it factored. We know that both 6x and 3 minus 1x is going to give us 0. So 6x equals 0. Hence, we can say that x is going to be 0 for the first turning point, because if we divide 0 by 6, we're just going to get 6. So for next, we know that 3 minus x equals 0. And if we make x the subject of the formula, let's just move it to the other side to get rid of its negative sign. So we'll add x on both sides, and we should get 3 equals x. So x is going to be 3. Now that we have both of these x coordinates, remember, we're not done. We need to find the y coordinates. So all we have to do is substitute them back in the original equation. Remember, not the differentiated equation, the original equation over here, which is 10 plus 9x squared minus 2x cubed. So first, we have x is 0. So let's just put in 0 there. And if you put 0 into 9 minus 2 into 0 plus 10, that should give you 10. So we know the first y is going to be 10. And y2 over here is going to be 10 plus 9 into 3 squared minus 2 into 3 cubed. Just put that in your calculator and you should get 37.
And also, I think like you are showing the substitution, it's very important to show that, right?
Yeah, it's really important to write this so they know that you where you've taken y from and that you haven't just like pulled it out of the air and how you found y. Yeah, okay. Okay, question 9, part A. Jana and Kamal each invest $8,000. At the end of 12 years, they each have 12,800. So it means both Jana and Kamal have 12,800. Jana invests in an account that pays simple interest, remember simple, not compound, at a rate of R percent per year. Calculate the value of R. So we know first, let's put in the formula for simple interest. We know it's just going to be P, the principal amount, into R, which is the interest, into T, which is the time, divided by 100. Okay, so this is going to be the interest she earned. Okay, remember not the entire value in her bank, just the interest she earned. But remember, the entire value in the bank is 12,800. So once we calculate this, it's just going to be the interest she earned. So the value in her bank, we have to add this to her initial amount, which was 8,000. Okay. We also know that the total amount they have, A over here, let's say A, is going to be 12,800. So we can substitute in that. Let's substitute in all the values actually. So 12,800 is going to give us her initial amount 8,000 into R, which we don't know, um yeah, into T, which is going to be 12 years, divided by 100 plus 8,000. So first, to get rid of 8,000, we're just going to subtract it from both sides. So if we do 12,800 minus 8,000, you should get 4,800. Let's write that over here. Or actually, let's write that up here. 4,800 equals, now we have this full thing, 8,000 into 12 into r, divided by 100. So first let's multiply, no, sorry, first let's get 100 on the denominator, multiply both sides into 100. So 4,800 into 100 is going to equal 12 into 8,000 into r. So again, let's get rid of this 12 into 8,000. So we just have r on the right hand side. So we're gonna have to divide both sides by 12 into 8,000. So that's going to be 4,800 into 100 divided by 12 into 8,000.
Yeah, please be careful with the number of zeros also. Sometimes you forget to plug in. Like there are 5 zeros, you plug in four.
Yeah, make sure you
Uh,
count all your
yeah.
zeros and don't forget the brackets. And after this, you should get 5. So we have r equals 5. Okay, to the next question. Kamal invests in an account that pays compound interest at a rate of R% per year. Calculate the value of R. Okay, so she, remember, Kamal has invested the same amount, except she's paying for, I mean, she's in the account pays compound interest. So we know that for compound interest, we know that A is going to equal P uh, into 1 plus r, over here it's going to be capital R, by 100 to the power n, which is going to be the number of years she invested it for. So let's go back up and look at the information. So we know that the principal is 8,000, and we know her total amount is 12,800, and the number of years are 12. So A over here is going to be 12,800 equals, and we know her principal amount is again 8,000, into 1 plus r by 100 to the power 12. Okay, so first, let's let's divide both sides by 8,000 to get rid of this one on the top. Um, and put that in your calculator, and you should get 1.6. So 1.6 equals 1 plus r by 100 to the power 12. So now that we have this power on the side, let's get rid of this by taking the 12th root of this. So that's going to be 1.6, and we don't want the 12th root. So now we can cancel out this power. So if you put that in your calculator, you should have a button that allows you to put in which root you want, and put 1.6, and that should give you some decimal. But I mean, over here I'm going to write it off into a few significant figures, but you should leave the full thing on your calculator. So, I mean, you should get something similar to 1.4 equals, I mean, you should get 1.0399, something around that. So that over here we have that now. So that'll give us 1 plus r by 100. So again, let's subtract 1 from both sides and to give us r by 100. So we subtract 1 from this side, we should get 0.04 equals r by 100. So again, to find just r, to isolate r, let's multiply both sides by 100, and we should get 4. Okay. Um, Hold on. Okay. Also, if you, I mean, you should get 3.99, which you can round off to 4. The population, I mean, oh, don't forget, 3 significant figures. Okay, the population of a city is growing exponentially at a rate of 1.8% per year for each year. The population is now 260,000. Find the number of complete years from now when the population will first be more than 300,000. Okay, so for these type of questions, it's mostly trial and error to find the number of years. So we know that for exponential rate, what we have to do is similar to the compound interest formula. So the population is now 260,000. So we have to just multiply that into 1 plus 1.8 by 100 to the power n. So what we want here is n, and this over here is going to equal 300,000. Okay, so first let's just get rid of this 260,000. So if you put that in your calculator, 30 divided by 26, you should get 15 by 13, which I mean we can leave it as this fraction. So now we need to find 1 plus 1.8 by 100 to the power n. So how many times do we need to put this in, I mean how many powers until we get 1.154, something like that. Okay, so first let's try 1 plus 1.8 divided by 100. If you put that just that in your calculator, you should get 1.018. So now let's try 1.018 to the power 2. So 1.018 squared. If you put that, that should give you 1.036. But remember, we want 1.154. So that's much more. Let's try 1.018 to the power 5, because this is really small. We need a much bigger number. 1.018 to the power 5. And you should get 1.09 something. Again, this is too small. So let's increase it. 1.018 to the power 8. And you should get 1.153. So remember, we want 1.154. So let's just increase it by 1 more power, which should, I mean, that should be our answer, because remember, these years are complete, so we can't have decimals as powers. So 9, if you do 1.018 to the power 9, we should get 1.17. So this is a little bigger than 1.154, but remember, they want from now on the population will first be more than 300,000. Okay, so this is our answer over here. To power 9, and since n equals 9, we know it's going to be 9 years. Okay, the table shows some values for y equals 2x cubed plus 6x squared minus 2.5. complete the table. So for this part, all we need to do is substitute in the x value into this equation. So I mean, you don't really need to show them any of your working for this. All you need to do is put them, but sake of this, I'll show you. Okay, so first, let's take minus 3. So it's going to be 2 into minus 3 whole cubed plus 6 into minus 3 whole squared minus 2.5. So if you put that, you should get minus 2.5. Okay, so let's do the same thing. Instead of the minus 3, put in minus 0.5 over here in your calculator, and you should get minus 1.25. And lastly, just put in 1, and you should get 5.5. Okay, so I've put in the table over here, and we need to draw the graph. Okay, so first let's look at the graph and let's calculate how much one box is for both the x-axis and the y-axis. So on the x-axis, we can see that for 1, there are 20 boxes. So one box is just going to be 1 by 20 or 0.05. And on the y-axis, there are 5 boxes for one increment. And so that means one box is going to be 1 by 5 or 0.2. Okay, so over here we have minus 2.2, 2.4, and 2.6. So I want minus 2.5, which can be somewhere in between there. So let's just take that over here. And that should be on this point. So we can just draw a little cross. Okay. Now our next point, sorry. Yeah. Our next, remember, draw crosses for these. They don't like circles. Either circles with crosses or plus signs. They don't like dots. So yeah. Okay, for our next point, minus 2.5 and 3.75. So minus 2.5, let's first assign minus 2.5. So minus 2 is over here, and we know minus 2.5 is going to be 10 boxes later. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Don't just estimate, make sure you've counted 10 boxes, because sometimes you can make a mistake. 6, 7. Yeah, and it's always better to recheck. Okay, so now 3.75 on the y-axis. So we need to let's find 3.75. So that's 3.2 would be here, 3.4, 3.6, and 3.8. So 3.75 is closer to 3.8. So let's take that as at 3.8. So somewhere over here. Now that we have that, we can draw the cross. I'll make your crosses smaller, but since I'm on a laptop, it's a little difficult. Yeah, your crosses should be really small though. Okay. For the next point, we have
Sorry,
minus.
sorry. Should we make it a little less than 3.8? Or did we just.
No, I mean because the increments are like 0.2, so it's between 3.6 and 3.8, and it's at 3.75.
It's barely,
So
but okay.
like there's
I'm
no
kind of.
just. I mean,
Yeah, yeah, I guess. I don't know.
okay. Okay. So for the next point, which is at minus 2, which we already have over here, it's at 5.5 in the y-axis. So 5 is over here, 5.2 will be here, 5.4, and so we know it's right in between 5.4 and 5.6, 5.6, so that will be right here. Hold on. Yeah, so don't forget to make sure it's like right in between. It's going to be somewhere over here. And extrapolate it, use your scale and extrapolate it all the way to wherever it needs to be. And in this case, it's 2, which is over here. So now we just again draw the cross. Okay, our next point is going to be minus 1.5 and 4.25. So on the x-axis, minus 1.5 is again going to be 10 boxes after 1. So just count 10 boxes. 1, 2, 3, 5, 6, 7, 8, 9, and 10. It's going to be over here. And let's do it for the rest of these values. 0.5, let's also put that one over here. So it's 1, 2, 3, 4, 5, 6, 7, 9, 10 over here. And then we'll do it for 0.5, and that was minus 0.5. That's going to be 10 boxes after 0. So 1, 2, 3, 5, 6, 7, 8, 9, 10 over here. Okay, so now let's do it for to the y coordinate of minus 1.5, and that's going to be 4.25. So over here we know 4.2 is going to be here, and 4.3 is over here. So 4.4 is over here. So 4.25 is going to be closer to 4.2. So if you're able to do it just a little bit above 4.2, that would be good. But if not, I mean, you could also just put it at 4.2. Okay, so that's this point. Oh, yeah. Okay, and the next point, minus 1, which is going to be at 1.5 on the y-axis. So over here we know 1.2, 1.4, and 1.6. So again, right in between 1.4 and 1.6. And just extrapolate that with your scale, and then draw the x. Okay. 0.5, sorry, minus 0.5, and over here it says minus 1.25. So let's find that. So minus 1 is over here, and minus 1.2 is going to be right below minus 1, and minus 4 is the next one. So we can't put it right between minus 2 and minus 1.2 and minus 1.4 because it's minus 1.25, which is closer to minus 1.2. So just take it somewhere closer to minus 1.2. And we know it's along this line, so we can draw the cross. Okay, the next point, 0, which is at minus 2.5. So minus 2, minus 4, and minus 6. So again, in between minus 4 and minus 6. Minus 4 and minus 6, so that's going to be somewhere here. Okay, the next point is 0.5 and minus 0.75. So on the y-axis, minus 0.75. So we know this is minus 0.2, this is minus 0.4, this is minus 0.6, and this is minus 0.8. Hold on. Yeah, this is minus 0.8. So it's going to be closer to minus 0.8, but you can put it slightly above minus 0.8. To show that it's not exactly at 0, and if you're able to do it. But if you're out of time or in a rush, just put it at minus 0.8. Okay. And lastly, for 1, the coordinate is going to be 5.5, and that's all the way on the y-axis up here somewhere. So 5.2, 5.4, and 5.6. So remember, right between over here. Now we can just draw the cross. Get rid of this line. Okay, so now you need to draw a line through your points, and it's difficult to do on the computer, so I've generated one. And remember, your line should be a smooth line graph like this. Okay, part C. By drawing a suitable straight line on the graph, on the graph, solve the equation 2x cubed plus 6x squared equals 4.5. So first, let's rewrite this so it looks similar to the other one by making this 2x cubed plus 6x squared minus 4.5 equals 0. So we just subtracted 4.5 from both sides to put it in this format. And now let's rewrite our other equation over here, which is the graph. 2x cubed plus 6x squared minus 2.5. 2x cubed plus 6x squared minus 2.5. 2.5 equals 0. So, what have we done? The question is to find the line on the graph. We need to know what has been done to this equation, the first equation, to make the above equation. So, what's different between these two equations? The second one, let me just number these. Equation 2 and equation 1. So, equation 2 has minus 4.5 instead of minus 2.5. So to find, we can just find the difference by subtracting equation 2 from equation 1. Okay, so we can just put over here minus 2x cubed minus 6x squared and minus minus 4.5 equals 0. So now if we subtract these, over here you should get 2. Yeah, so in a sense, you're just doing 2.5 plus 4.5, and that should give you. Wait, sorry. 2.5 plus 4 minus 2.5 plus 4.5, and that should give you 2. So now we know that our equation over here is we know that our equation over here is y equals 2. Okay. So now that we have this, we just need to draw the line at y equals 2. So the line at y equals 2 over here is over here. Y is equal to 2 on this line. So let's draw a line throughout that entire y equals 2. It should look something like this. Now we have the line, and they want us to solve the equation. So to solve the equation, all we need to do is find the points where the line and the graph intersect. So that would be over here. These 3 points over here and over here. Yeah, over here. Okay, so for the first, hold on. Okay, so remember they just want the x coordinates, so we can just draw lines down to find these x coordinates. So the first one is going to be over here. Okay, so what is this x coordinate? We know that 10 boxes, and we know one box we've calculated to be 0.05. So and we know over at this point it's going to be 2.5. So 2.55 would be here, 2.6 would be here, 2.65 would be the next one, and 2.7 would be where they intersect. Sorry, minus 2.7. If you've drawn your graph accurately, maybe your value might differ a little bit, but it should be around minus 2.7. Okay, so for the next one, again, let's draw a line down again from when they intersect. It should be over here somewhere. Right in between two values. Let's make the line thinner. Okay, so we know that again each plot is 0.05. So it would be 1.05 would be over here, and the next one would be 1.1. So we can say it's somewhere around minus 1.1. Don't forget the minus sign. Uh, and lastly, over here, so again, let's just draw a line down. Okay, and over here we know that this point over here is 0.5, and that each plot is 0.05. So that means over here would be 0.75, and this last one would be 0.8. So that's going to be x equals 0.8. And remember, if your values are slightly different, that's fine. They will always have a range, but based on how your graph, if you draw your graph accurately, you should get the points accurately. Okay. Um, the equation 2x cubed plus 6x squared minus 2.5 equals k. So this over here is just our equation that they've given above. So they're equating this to a random y value, and they're saying it has exactly two solutions. Write the two possible values of k. So that means the point at which there are only two, for any wherever we draw. If we draw a y value line like over here or over here, there should only be two solutions wherever we draw it. Um, so over here we can clearly see that there is this point. I mean, if we draw a line over here, we could try to put this to two solutions, and it seems to only have two solutions. Let's try it down below also. If we draw a line at the lowest y value, we are also only getting two solutions. So that means, like they said, there are only two possible values of k. So you can try drawing the line anywhere else if you're confused. Over here, you can clearly see the line intersects 1, 2, 3 times with the graph. So we know it's not there. And anywhere in between, in fact, it's going to intersect more than twice. And you might also ask, above these values, where the line does go above, you would only get one value. So it's only these two values. So let's find these two values. So we know the first one over here is this where we first plotted it. Let's find where we've plotted the top value, and that is going to be 5.5. Again, we can see that we have written 5.5 twice, so we know that it's 5.5. So k equals, oh sorry, yeah, k is going to equal to 5.5. Now the second value of k, where else are there two y values? We can just again look at our table for this. So where else, what other values repeats twice? And it's going to be the smallest value, which over here is nothing but minus 2.5. So minus 2.5 here and a minus 2.5 here. And again in our graph, it's here and here. So minus 2.5 is our other k value. Okay. Question 11. So they've given us three functions. The first one is f of x equals 1 by x, and we have to know that where x is not 0 in any of these cases. The next one is g of x is equal to 3x minus 5. And the last one is h of x equals 2 to the power x. So first they want us to find g of f of 2. So to find this, what is this? We know this is nothing but g of x, where the x is equal to f of 2. So what we need to do now is substitute in um, f of 2 inside our g of x. So first let's find f of 2. f of 2 is going to be equal to where we substitute 2 inside our f equation. So that's going to be 1 by x, and x over here is 2. That's 1 by 2. So now, hold on one sec. Yeah, wait, sorry. Yeah, okay, so now we have f of x is 1 by 2. I'm sorry, f of 2 is 1 by 2, and we need to put that inside our g of x. So let's make that g of 1 by 2, because we found g of f of 2 was 1, sorry, f of 2 is 1 by 2. So now we put f of 2 inside g of x, and so g f of 2, so this is nothing but g f of 2, by the way, yeah, equals g of 1 by 2, equals, yeah, 3 times 1 by 2 minus 5, where this is just g of x, and we substitute in 1 by 2 for x. Okay, so if you put that in your calculator, 3 divided by 2 plus 5, you should get 6.5, or 13 by 2.
No, it's minus 5. It would be minus 3 point.
Oh, sorry, yeah, sorry. Yeah, if you put that in your calculator, you should get minus 3.5, and that's our answer, so we'll just write it. Minus 3.5. Part 2, g inverse of x. So we know to find an inverse of the solution. Over here it's g of x. Let's find the inverse of, wait, yeah, they want us to find the inverse of g of x. We're going to write g of x as x equals, and we're going to write x as y. So 3y minus 5. So now all we have to do is make y the subject of the formula. So let's add 5 to both sides. X plus 5 equals 3y. And now let's get rid of the 3, so divide both sides by 3. 3. It's a little messy, but you can just write this as x plus 5 by 3. Okay. Part B, find in its simplest form g of x minus 2. So, if this is g of x, wherever x is, we need to replace this with x minus 2. Let's go back down to our, okay, so we know g of x equals 3x minus 5. Wait, hold on one second. Okay, equals 3x minus 5, and g of x minus 2 is going to be 3 times x minus 2 instead of x minus 5. And don't forget to add the brackets here around x minus 2. It's not x and then minus 2 and then minus 5. It's 3 times the whole of x minus 2 minus 5. Now we can expand this and multiply 3 into both the terms inside the bracket. So 3 into x is going to give us 3x, and 3 into minus 2 is going to give us minus 6. And then again we have the minus 5. So now we can add minus 6 and minus 5 and make that 3x minus 11. So that is our answer. Okay. Find the value of x when f g of x is equal to minus 1. So over here, all we need to do is substitute g of x into f of x. So that means we're substituting 3x minus 5 into this term over here. So first let's write f g of x is going to be 1 by, and now over here we're going to substitute in g of x into the x term, which is over here in the denominator, and which is 3x minus 5. So that'll be 1 by 3x minus 5. And we know this full thing is going to be equal to 0.1. So now all we need to do is move this 3x minus 5 to the numerator by multiplying both sides by 3x minus 5. So we'll get 1 equals 0.1 into 3x minus 5. So now let's expand the brackets. 1 equals 0.1 into 3x, which is going to give us 0.3x minus 0.1 into 5. Or plus 0.1 into minus 5, be 0.5. So now to make x the subject of the formula, let's remember we need to add 0.5 to both sides. So we could also change this an easier, wait, hold on. So first let's do this. So first let's add 0.5. So 1 plus 0.5 would be 1.5 equals 0.3x. And now to get rid of the 0.3, we just divide both sides by 0.3. And another way to do this would be, we know that 0.1 over here is also equal to 1 by 10. So now when we cross multiply, we know that 1 into 10 is going to equal 1 into 3x minus 5. So 1 into 10 is going to be 10 equals 3x minus 5. And now again, we just add 5 to both sides. 15 equals 3x. And again, now to get rid of this 3, we divide both sides by 3. And so x is going to be 5. I think writing this as a fraction is the easier way, but again, you can also do it like as straight as 0.1, and you put this in your calculator, it should also give you 5. Okay. They want h of x minus g of 7 equals 0. Okay, so we know h of x over here. They've given us h of x to be 2 to the power x. Okay, so 2 to the power x minus, now we just substitute 7 inside g of x. And so that's going to be 3 into 7 minus 5. So let's go back down. Minus 3 into 7, because g of x is 3x minus 5, and now x is 7. So minus 3 into 7 minus 5. So remember this whole thing. So now let's expand the brackets. We can rewrite this as 2 to the power x minus, so now let's expand everything inside the brackets. 3 into 7 minus 5. If you put that in your calculator, you should get 16. Now we have 2 to the power x minus 16 equals 0. Okay, so now we have 2 to the power x minus 16 equals 0. We can rearrange this and write this as 2 to the power x. Let's add 16 on both sides, so 2 to the power x equals 16. And we also know that 16 is a power of 2. We know that 16 is 2 to the power 4. So again, we can write this as 2 to the power x equals 2 to the power 4. And we know that for a to the we know when there's a to the power x, when this is a to the power y, x has to be equal to y. So therefore, x has to be equal to 4, because 2 to the power x has to be 2 to the power 4. So that gives us x as 4. Okay. Okay, for the last question. The diagram shows a circle of radius 12 centimeters with a sector removed. Calculate the perimeter of the remaining shaded shape. Okay, so we know that for a circle, when we for if this much is 50 degrees, then this entire angle is going to be 360 minus 50, because we know that a full circle is 360. So if you do 360 minus 50, you should get 310. Okay, and we know that also the perimeter of this entire sector is, we know that it's going to be x by 360 into 2 pi r. So that over here is going to be replaced by 310. So we do 310 by 360 into 2 pi r. And over here r is 12. So we can write this as 2 pi into 12. So now just put this straight in your calculator and use the pi button. 310 divided by 360 into 2 pi into 12. And you should get 62 by 3 pi. And right now we'll leave it as pi before we get the final answer because we don't want to mess up any of our other calculations. And remember, lastly, we need these bits. We know that we found the entire we found this shape. Now we also need these shapes, and we know that these lines. We know that it's 12. The radius is 12, so it's going to be 62 by 3 pi plus 2 into 12. So now just add 2 into 12 into the number in your calculator. It's 24. And you should get 88.92 something. 88.926. Okay, and to round it off to three significant figures, you should get 88.9. Okay, for the next question. The diagram in part A shows the top of a cylindrical cake with the slice removed, and the volume of the cake that remains is 3510 centimeter cubed. Calculate the height of the cake. Okay, so we know that the volume that remains is this much, and we also know that the volume of cylinder is equal to pi r squared h. Okay, pi r squared h. Okay, and remember, it's not saying the full cake is the volume, but the volume of the cake that remains. That's pi r squared h minus the little pyramid that we just took out, minus this volume. Okay, so hold on. Yeah, so to do this, we know that we have our angle as 310. And wait, hold on, sorry, one sec. Um, okay, yeah, wait, sorry. Yeah, let me restart. Okay, yeah. And we also know that over here we don't want the full cake, we just want the rest of the angle. So to calculate the volume, it's the same thing, except so we need to multiply whatever we have into the angle. So instead of 1 into pi r squared h, it's going to be the amount that we have, which is 310 by 360 into pi r squared h. So that's the volume remaining, and that's going to be. And how do you know it's that? It's because just like how we've had for the parameter, it's just the angle into the actual formula of parameter, which is 2 pi r. Just like that, we're multiplying the actual formula of the volume into the angle. So this much is going to give us 3510. So now remember we just want to find h. We already know r. Okay, so now we want to make h the subject of the formula. So we're going to take everything else to the other side. So let's rewrite this. H is going to equal to 3510 divided by, now we need to get rid of all these multiples by dividing both sides by these multiples. So 310 by 360. Okay, and again, we also need to divide it by pi and r squared, which is 12, so 12 squared. And if you put this in your calculator, you should get h as equal to 9.009. And to write this in three significant figures, we can round this up to 9.01. And that is our final answer. Thank you so much.
Yeah. Good job, everyone, for staying through the video. Thank you so much. Um, and we'll see you in the next video where Varchini takes you through another past paper. Yeah. Bye.
Bye.